guys already know what the parent graphs of sine and cosine look like. But we're going to go through them a little bit more carefully to kind of make some connections that maybe you haven't made before about how this all works. So if we're going around the unit circle, and I'll do the sine first, so f of x equals the sine of x. The first angle we do the sine of is a 0 degree angle, and what's the sine of a 0 degree angle? 0, right? So if I kind of make a table of values to go along with this, 0, pi over 6 will be my 30 degree, my 45 degree, my 60 degree, and my 90 degree. So the sine of 0 is 0. The sine of pi over 6 is 1/2. Sine of pi over 4 is root 2 over 2. Sine of pi over 3 is root 3 over 2, and the sine of pi over 2 is 1. So when we go to plot this right now, our x-axis is in radians. Our y-axis is going to be like between -1 and 1. So I might make this 0.25, 0.5, 0.75, and 1, just to use the whole graph. And 3 of those 5 points I can definitely plot. 0, 0. Whereabouts is pi over 6? What is this? If this is 0 and this is pi over 2, what's this? Pi over 4. Very good. If it helps you to kind of estimate, pi over 6 is 30 degrees, and these 2 hash marks are 90 degrees, right? Right? This whole section is 90 degrees long. So 30 degrees would be about a third of the way there, so I'm going to say that pi over 6 is probably about here. So pi over 6, 1/2. Pi over 4 is root 2 over 2. We need to cheat. Because our y-axis is scaled in decimals, we need to see what root 2 divided by 2 is. 0.7-ish. 0.7, just so under 0.75. And then pi over 3 is like a 60 degree angle, so that's 2/3 of the way to the pi over 2. And again, we got to cheat a little bit. Square root of 3 divided by 2 is 0.866. So we'll do 0.87-ish. And then pi over 2 is with 1. So we just did a 30 degree angle, a 45, a 60, and a 90. And we had those values. And then what's the next angle that we get to? And if we think backwards, what will the reference of that be? What's the reference of this next tick in my process? So I'll have one there, I'll have one there, and then I'll have this one. What's the reference angle of this? Children, talk to me. I find it impossible that you don't know. Nate, take a guess. A reference angle has to be between 0 and 90. But you're right, it is a 120 degree angle, but what's the reference of that? (120 to 180). 60, and 60 degrees though in radians is pi over 3, right? This was 1 pi over 3, so this angle is going to be 2 pi over 3. And what's this one going to be? Reference angle of what, Joey? pi over 4, right? So this is 1 pi over 4, this is 2 pi over 4, this will be 3 pi over 4. And then reference angle here, Mitch. Yeah, you gave me the angle, that's fine. That is 5 pi over 6. I should be doing these down here, because I'm saving that end space for the actual value. So this is just kind of telling us what our next, and then what would our final angle right here be, Bridget? Or just pi. So now if we go through each of those, based on all students, all of these sine values will continue to be positive, right? And we see that on the graph because, as you know, this is going to come down. It's going to start to decrease, but it's still positive because it's still all above the x-axis, right? So the sine of 2 pi over 3 is going to be the same as the sine of pi over 3 was, root 3 over 2. The sine of 3 pi over 4 is going to be the same as the sine of pi over 4. And then the sine of 5 pi over 6 is going to be the same as the sine of just plain old pi over 6. And then the sine of pi is 0. So when you plot the next quadrant's point, so here's Q1, here's Q2, 2 pi over 3, root 3 over 2, 3 pi over 4, root 2 over 2, 5 pi over 6, a half, and then pi 0. So that first stretch is Q1. That second stretch is Q2. We follow? And we're going to keep going into Q3 and Q4. So, when we come here, what is that angle? If we're kind of ticking around the clock here, what angle would that be? Oh, Marissa. Do you know the reference angle of it? No, because, see, we haven't got, so we're going to go here, here, and here. And the reference angle, like what's your main, go degrees for a second for me, because I think that's probably easier for you. What's the initial reference angle when you, the smallest of the three? 30, and then this one will be 45, and then the last one will be 60. So since that's a 30, then the reference angle is pi over 6. So how many pi's over 6 is this one? 7 pi over 6. Very good. And then this next one is our pi over 4. How many pi's over 4? John? How many pi's over 4 is this one? So this is? No. Look at 0 pi over 4, 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4. It's just one tick past 4 pi over 4. When I say one tick, it's not obviously the first ray past it, but it's the first pi over 4 ray. So we just count by ones as we keep going to each subsequent pi over 4. This is your pi over 3 reference. How many pi's over 3, Connor? 4 pi over 3. And then we finally get to 3 pi over 2. So a reference angle of pi over 6 is going to still be 1/2, but all of a sudden we're negative because we're in the quadrant where sine is negative and only tangent is positive. So rather than being 1/2, it's going to be negative 1/2. Rather than being root 2 over 2, it's going to be negative root 2 over 2. Rather than being root 3 over 2, it's going to be negative root 3 over 2. And rather than being 1, it's going to be negative 1. And as you know from your two-dimensional parent graph, you know that this is when it finally drops into the negatives. So 7 pi over 6, negative 1/2. 5 pi over 4, negative root 2 over 2. 4 pi over 3, it's negative root 3 over 2. And then 3 pi over 2 brings you all the way down to negative 1. So there's your Q3 section. So you have Q1, which brings you to pi over 2. You have Q2, which brings you to pi. You have Q3. And then we just have to make our way through quadrant 4. So, Aiden, what will this be? Pi over 3 is correct. So if do you guys realize that as we go around, our reference angle is 30, 45, 60, 90. It's on the rise, and then it goes back on the decline, 60, 45, 30, 0, right? And then we start increasing again, reference angle of 30, 45, 60, 90. Then we start declining again. So this is the reference angle of 60, which is pi over 3. And if this is 3 pi over 3, then this is 6 pi over 3. So one tick prior to 6 pi over 3 is 5 pi over 3. Is that sort of the logic that you used, Aiden? Or did you do it differently? Pi's over 3. Yeah. So you knew. So you did it. You just went around forwards versus backwards, which is fine. And then this next one is a 45-degree angle, which is a pi over 4. So here's 8 pi over 4. So one tick before that is what, Nate? Yep, 7 pi over 4. And then here's your pi over 6. This is 12 pi over 6, so one tick before that is 11 pi over 6. And then, of course, we're back to a full 2 pi. So, again, all students take calculus. The fourth quadrant is only positive if it's cosine. So all of our values here will be negative because we're taking the sine. So 5 pi over 3 is going to reflect pi over 3, but it's just going to be negative. 7 pi over 4 is going to reflect pi over 4. It's just going to be negative. Then we have negative 1/2, and we have 0. So when we bring this back, and then this is Q4. So what I like about doing that side by side with our unit circle rotations is you can see on a sine graph all students take calculus kind of working. Everything should be positive here. All of your functions are above the x-axis in this first stretch. Then in your second quadrant, only your sine function is positive there. When we look at the graph of your tangent function, your cosine functions, they will be underneath the x-axis, but we're still positive because we're doing a sine here. And then only tangent and cosine are positive in quadrants 3 and 4 respectively, so therefore sines are in the negative and underneath the x-axis. Now, we also just went around our unit circle like that. We could keep going. If this is 12 pi over 6, this would be 13 pi over 6, right? And then we would keep going, and all of these would be coterminal to what we just did, which is kind of why this also keeps repeating. This little pattern of it keeps repeating. You follow? Okay? And vice versa, going into the negative angles, we could just start going backwards. So negative pi over 6 is going to be a coterminal to what was our 11 pi over 6. So if we go back to negative pi over 6, we're still at negative 1/2. If we go back to negative pi over 4, we are a coterminal to 7 pi over 4. So negative pi over 4 is going to be a coterminal to that one. Negative pi over 3 is going to be a coterminal to 5 pi over 3, which was here. Negative pi over 2 is a coterminal to 3 pi over 2. And so you kind of see when you're moving your little unit circle ticks backwards, you're just going backwards and retracing all of these, which is why this pattern kind of repeats going left as well. So we don't really need to graph every individual little point in between like we've been doing. We just know that's your fourth quadrant. There's your third quadrant. There's your second quadrant. And there's your first quadrant. All repeated. So the same reason that this little 0 to 2 pi cycle repeats is the same kind of repetition that you see if you just keep winding round and round and round the unit circle. Does that make sense? Okay. We're not going to do nearly as much detail for cosine of x. We'll maybe just do the first quadrant because we know it. What's the cosine of 0? 1. Cosine of pi over 6. Cosine of pi over 4. Cosine of pi over 3. Cosine of pi over 2. So if I use the same scale, cosine graphs start at 1, and then by the end of their first quadrant, they're down to 0. And then by the end of their second quadrant, they're down to negative 1. And then by the third quadrant, they're back to 0. And then by the full circle, they're back up to the top. So you get something like that, which again I like. Here's quadrant 1, quadrant 2, quadrant 3, quadrant 4. All students take calculus. The only place this graph is above the x-axis is where the A is and where the C is. And in the other two quadrants, it's negative. And obviously this repeats as well. Okay, so on your notes, in this first exercise, we have to back up to your basic format of trig functions, which can be different depending on what textbook you look at. They all will end up being the same thing, like final answer-wise, but some of them present it a little bit differently. I just want to, I can't remember which way your calculator does it. So I have some points in here. I'm just making this up. Oh no. Hold on. Okay. So you know how like if you do a scatter plot and a regression kind of thing, you can do a trig regression and it will always give you at the top of the screen. Is this going to work? Oh, shoot, I'm not on. I'm not on. Oh, you know what's probably the problem? Can you guess? I've got answers bigger than 1. 0.2, 0.5, 0.6. Will this do it? No. Hold on. I think I might have to turn this on. Am I not going to be able to... What are my invalid dimensions? List 2? I need help. Why doesn't it like those numbers? That's weird. Sine of anything has to be between... Oops, I don't want linear. What if I get rid of that? You guys. Oh. I see what you're saying. Come on, Aiden. Get the MVP award. No. I wonder if maybe I should be in radians. Well, then I don't care. I'm just going to tell you what my format is. So you'll have to tell me what Mrs. Zig used last year. I'm going to do it for Sine. Does that look familiar to you? You guys had to write sine and cosine functions last year. And this is the format you should have used. Sometimes people will have the B on the inside. I prefer the B on the outside because the C is not really meaningful unless that coefficient has been factored out in front. So from here, A was the what? If there was a 4 in there, what would that mean? Amplitude. The amplitude is technically the absolute value of A. B is what? Frequency. I actually don't talk too much about frequency. I really talk more about that B is used to help calculate the period, because period equals 2 pi over B. Do you remember what the C is called? Aiden? Starts with PH. Phase shift. Oh, it's all right there on your first problem. And D is your, do you remember? Midline. essentially all of those variables there really bring transformations back into it. This sine curve parent graph is shifted right c units. It's horizontally compressed by a factor of b, or stretched by a factor of b. It's then vertically stretched or compressed by a factor of a, and then it's shifted up or down, and that's why your midline, which is typically 0 on the parent graph, your midline is 0, gets shifted up or down with that d value. So we will start on Monday, we'll take each of these functions and we'll identify what's a, what's b, what's c, what's d, and go from there with your transformations. But one more thing over here. What is the amplitude of your parent graph? 1. What is the period of your parent graph? How long does it take you? 2 pi. That cycle repeats itself every 2 pi. What is your phase shift on the parent graph? 0, right? And your midline is also 0 on your parent graph. See, your amplitude is 1, that'll be the coefficient. Your b value is 1, so 2 pi over 1 keeps your period 2 pi, and your phase shift is 0, and your midline is 0. So I wasn't a liar after all. You have no homework. Take it all in, because this happens maybe 3 times a year.